In this video, we'll be going over palindrome partitioning. So given a string S, partition as such that every substring of the partition is a palindrome. Return all possible palindrome partitions of S. A palindrome string is a string that reads the same backwards as forwards. So in our first example, we're giving this string AAB and then we're trying to partition it into palindromes. So in our first array, each element is a palindrome because each element is only a single character. And then in our second example, we have A and A as a palindrome and B as a palindrome. AA is a palindrome because it can be read the same backwards as forwards. Let's go over the dot process. So for each of the starting index I, we will want to find a palindrome from I to j, where j is greater than or equal to I. After finding a palindrome from I to j, we will want to find the palindrome partitions from j plus 1. Then we can prepend the current palindrome to all of the palindrome partitions from j plus 1. Now, another thing we'll take care of is how can we check if the current substring from I to j is a palindrome. We can implement a two-pointer approach. So one pointer I will be on the left side, and then one pointer j will be on the right side. Then in each of the iteration, we will be comparing the two characters at the indices before moving both of the indices closer together toward the center. So we will want to make sure the two characters are the same. Now let's go over the pseudocode. So we're going to implement, before that we're going to validate the input parameter. So if S is empty, there's no palindrome partitioning, so we can just return an empty list. Then we're going to implement our recursive approach to find all of the palindrome partitionings. And the first one is, what parameters do we need? The first one we need are I, our current starting index, initially 0. And then we have our S, our input string. And then in each of the recursive call, we're going to create a list results to hold all of the palindrome partitionings. Then we're going to first check if I is out of bound, then there's no more partitionings to be made. We can add an empty list to results, and then we can return results. Then each of the recursive call, then when it iterates, before that we're going to create a string builder, str, to keep track of the current string, or the current substring. Then when it iterates through the indices from j to n of string s, which is going to denote it as j, it's I to the n of string s, denoted as j. I'm going to append the current character at j to string. Then I'm going to check if the current substring is a palindrome or not. If the current string from indices I to j, or we should say substring, is a palindrome, we will want to recursively find the partitions, the palindrome partitions starting from index j plus 1. Then when it iterates through the partitionings that we have found, denoted as PAR, we want to append or prepend the current palindrome substring to each of the partitions that we have found. So we're going to create a list partition to keep track of the current partition, and we're going to add a string representation of string to partition, and then we're going to add all of par the partitions we have found to partitions to partition, and then we're going to add partition to results. Then we can return a resulting list, which holds all of the palindrome partitions from the starting index I. Let's go over the code. So we're going to first validate the input parameter. So if the input string is empty, we can just return a new list or empty list because there's no partitionings. And then we can find the partitions starting from index 0 and the input string. And then we're going to create our help method to implement our recursive approach, our starting index I and our input string s. Now we're going to create a list results to keep track of all the palindrome partition starting from index I. Then we'll first check if I is out of bound. This means there's no more partitions left to be made. We can add an empty list to our results. Then we can return the results. Now I want to create a string builder, our current, to keep track of the current substring. Then we iterate through all the indices from I to the end of the string, which we denote it as j. We're going to append the current character to our string builder. Then we want to check if the current substring is a palindrome or not. Let's create our method to check if it's a palindrome. So we can create a private boolean to check if a substring is a palindrome from I to j. And then we can say while I is less than j, if the current characters, if s.char at I is not equal to s.char at j, then we can just return false. And then after we compare them, we want to move them closer together. So we increment our I and then decrements our j. This is post increments and post decrements. Then we can return true if all of the characters matches. Now, if the current substring is a palindrome, we want to find the partitionings from starting from j plus 1. So partitions starting from j plus 1. And then we'll iterate through all the partitionings. And then we want to prepend our current partition, our current substring into each of the partitions. Then we want to create a new list called partitions. New array list. We want to add our current string first, or we can just call it partition. Add the current string, the current substring, and then we can add all of the current partition, and then we're going to add the current partition to our resulting list, and then we can return our results. Let me know if any questions in the comment section below.